This is Geometry, Unit 10. This is the review for the unit. Here for number 1, we're looking at a rectangle for a base. And we notice rectangles going up the sides. So we call that a rectangular prism. Our cross section, we're going to be parallel to our base. And if we call the base on the bottom, we're going to be parallel to that. Then the shape that's going to be formed, that would be dashed in the background, that shape would become a rectangle also. The stamp that's formed when you run your plane through and do a cross section would be a rectangle. As long as you're parallel to the base, it's going to be the same shape as the base. Next we have a pyramid. It's a special type of pyramid. Notice that all the sides of the base are the same length. Let's also consider this to be a right angle, which would make it a square. So we could call this a square pyramid. In our cross section, it would come through, it would touch the pyramid there and across, and notice that that shape, the cross section it's called, is the same as the base of the pyramid, which is a square. For number 3, we have a cylinder, and when we run our cross section through here, if we took off this top portion and made a stamp out of it, we would get circles. Or a circle is actually the best way to write that. Here we have our base, which is a triangle. We have one on top and one on bottom. Rectangles on the side. So since the bases, it's doing the same shape all the way through, they're triangles all the way through. It's called a triangular prism. And our cross section, parallel to that base, is also going to be a triangle. As long as the cross section is parallel to the base, it's going to be the same shape as the base. Here we have a cone. It's a circle for a base that goes up to a point. When we do our cross section, we could take off the top cone, make a stamp out of it, and you would see a circle. Finally, we have a sphere. If we did a cross section, you took off the top portion, made a stamp out of it, you would make a circle. On the opposite side, we're looking to find the volume of the solid. We know that the pyramids are regular and the prisms, cones, and cylinders are all right. We're going to round our answers to the nearest hundredth. So we can draw in the part that we can't see. You could look at this rectangular prism in two different ways. You could look at it like a fish tank, where you fill up the fish tank and the water starts across the bottom and then fills up. Or you could look at it like a loaf of bread, where you would slice off piece after piece after piece and work from one side to the other. Either way you do it, you get the same answer. The volume is the base times the height. This is the one shape that you can decide for yourself what the base is. The base that I would typically talk about for a rectangular prism would be from the bottom, and then we'd fill it up kind of like a fish tank. So 11 times 5, that would be the area of the bottom. Then we times it by 6. Regardless of how we did that, we would come up with the same result. So with our calculator, we'll say 11 times 5 times 6 to come up with 330 centimeters cubed. The next shape is a pyramid. This is a square pyramid. It has all the base sides the same length with the tick marks. It has the right angle. So we know that the volume is 1/3 base times height. Now the base is the area of the base. The capital B is the area of the base. So for this shape, the area of the base is a square, and we do that by 7.42 squared, because it's 7.42 times 7.42 times the height, and they give us the 9.25 as our height. Right down the center of that pyramid. So we have 1 divided by 3 times 7.42 squared times 9.25. We got a volume of 169.76 meters cubed. Number 9, we have a cylinder. The cylinder, the volume of a cylinder is base times the height. Well, the base of every cylinder is actually pi r squared, so we can times that by the height. If the diameter is 16.6, then the radius is 8.3. So the volume is going to be 8.3 squared times 5 times pi. So we'll say 8.3 squared times 5 times the pi. So the volume is 1,082.12 millimeters cubed. Number 10 is definitely the most difficult one on this page. When we look at this shape, first we have to identify what type of shape it is. Notice that this side, it's a triangle, is repeated throughout the entire shape. So this is called a triangular prism. So we have to find the area of the base. That's a capital B, the area of the base. And then we times that by the height. And the height is actually the distance between the bases. So to find the area of the triangle, we have an equilateral triangle. All the sides are the same length. 10, 10, and 10. Well, if it's an equilateral triangle, if all the sides are the same, we also know it's equiangular. Well, if we drop our line down the center so that it is perpendicular to the opposite side, we still have our 60-degree angle on the side. We now have 90 degrees. The hypotenuse is still 10. So this is a 30, 60, 90 triangle. And we've learned that the short leg times 2 makes the hypotenuse of a 30, 60, 90 triangle. So I know that this is 5. I know that the long leg is the short leg times root 3. So the height of our triangle right through here would be 5 root 3. You can use the decimal version of that, or you can use the 5 root 3. 5 root 3 is more accurate. It's called the exact answer. So if this triangle, we'll say capital B is half, the base of this triangle is 10, the height of this triangle is the 5 root 3. So half of the 10 is 5. So the capital B is 25 root 3. So that is the area of this equilateral triangle. Now we're going to times that through the distance between the two triangles, which is called the height of the prism, which is 8. And that gives us 200 root 3. Those would be yards cubed. If you were using a decimal throughout the problem, you would get an answer of 200 times the square root of 3, which is 346.41 yards cubed. Either answer there would be accurate. The most accurate, the exact answer, is this one with the root 3. A rounded answer to the nearest hundredth is the second one. Number 11. We have a cone. The cone has a radius of 3.3 and a height of 6.8. So the volume of our cone, because it comes up to a single point, is 1/3 base times height. Well, our base is a circle, so it's always pi r squared, and our height, this is a right cone, that's what the direction said in the very beginning, it goes straight up. So the volume equals 1/3 pi 3.3 squared times our 6.8. We can take our calculator and use our parentheses for 1 divided by 3 times the pi times the 3.3 squared times the 6.8. We get 77.55. That's the volume of the cone. Finally, we have a sphere. The volume of a sphere is 4/3 pi r cubed. Well, our diameter is 6. Notice that the line goes all the way through the sphere, and the measurement is here in the middle. So the radius is going to be half of that. So the volume equals 4/3 pi 3 cubed. Well, this will be a good one to show you the exact answer for, because 3 cubed, 3 times 3 times 3 is 27. I can take 1/3 of 27, which gives me 9. I can multiply my 9 and the 4 to get 36. So I have 36 pi. Another way you could do that is to use your calculator and say 4 divided by 3 times 27, and that's going to give you 36. We haven't used the pi yet. If you want to put this into a decimal, then we take our 36 times pi, and we get a value of 113.10. That would be feet cubed. For either one of these answers, that would be feet cubed. For the final side, we're looking at number 13. This is again a triangular prism. We have two triangles and the distance between them is x. So lots of people were having some troubles with this particular question. Notice that you have a right angle. You have 17 across from that right angle. The 8 would be on this side. So we're going to look at this shape, and for us to calculate the area of the triangle, I need to know the two sides that are perpendicular to each other. So I need to know this third side. The 17 doesn't help me figure out the area directly. I need just to use it to find a different side. So I'm going to have to use 17 squared, which is the hypotenuse, plus leg squared equals this other side. Let's call it y squared. That's my y. So our 17 squared is going to be 289 equals 64 plus another number. We'll subtract the 64. And we'll notice that when we take the square root of 225, we get 15. So our missing side length is 15. So what we can do with that, the volume of this shape is actually base times height. Well, the base is a triangle. So the base is half of 15 times 8. Then we times that by the height, which is x. So 8 times 15 is 120. I know that the volume is 1,440. Half of 120 is 60. Divided by the 60 to figure out the x, we have 1,440 divided by 60 leaves us with 24. So the height, it's not quite drawn to scale, but the height is 24. Next we have a cylinder. The volume of a cylinder is always base times height, and we can call that pi r squared times the height. Well, 72 pi, that's the volume. The r is our unknown, that's our x squared. The height is the 2. So I'm going to divide by the 2 pi. Put that in parentheses. The 2's cross out, the pi's cross out. Divided by 2 pi, put that in parentheses. The pi's cross out and you get 36. Take the square root and you get 6. Next we have a rectangular pyramid. The rectangular pyramid is 1/3 base times height. It's 1/3 because it comes up to a point. It's base, so we have to find the area of the rectangle times the height, and that's our unknown x value. We know the volume is supposed to be 54. We want 1/3 of our base. Our base is the rectangle. 8 times 4. Our height is our unknown x. So we have 54 equals 1/3 of 32. Well, I can take the 54 and times it by the denominator. So I'm going to multiply 3 to both sides to get 162 times 32x and divide that by my 32. Either way I look at this, I'm going to get a decimal. So I have 5.0625. So if we rounded that to the nearest hundredth spot, there would be 5.06. Number 60. The volume of a sphere. The volume equals 972 pi. These are centimeters cubed. We're supposed to look for the diameter. Well, I know the formula is 4/3 pi r cubed. So if I take the 972 and I equal that to 4/3 pi r cubed, I can multiply 3 to both sides. And I'm sorry, that's 972 pi. That's a big deal. That would be a common mistake we talk about later. You need the pi there so when you divide by pi, they cross out and you don't mess with the numbers. But let's multiply by 3. So 972 times 3. 2,916 divided by 4, 729 equals 729 pi, leaves us with pi r cubed. Divide by the pi, and just those pi's cross out. So your 729 equals r cubed. So now you need to be able to take the cubed root. And this particular calculator, the cubed root is found underneath x cubed. The cubed root looks like a square root with a little number 3 above it. So I'm going to hit the cubed root. Notice how it has a 3 up in the upper left-hand corner. And I'm going to do that of my answer. So that means that 9 times 9 times 9 makes 729. That's what the cubed root means. It's looking for the number that you multiply 3 times to make that larger value. The cubed root of 729 is 9. So r is 9. D is going to be 2 times 9, which is 18. Number 17. Here we have what's called a hemisphere, and it's on top of our cylinder. We have half a sphere, plus we have a cylinder. So we're going to take half of 4/3 pi r cubed plus pi r squared times h. This gives us, we could reduce the 2 and the 4 if you like. So 2/3 pi. The r value is the 6. On this side, the 6 is still the radius, and the height is the 4. So 6 times 6 times 6 is 216. Here we have 36 times 4, which is 144, with the pi symbol. 216 divided by 3 gives us 72. Times 2 is 144. So that leaves us with 288 pi. That would be the exact answer. That would be excellent. Centimeters cubed. We can also take that in our calculator. If you wanted to type the whole thing in there originally, if you're just looking for a decimal version, we could say half of 4 divided by 3 pi times 6 cubed plus pi times 6 squared times 4. Comes up to be 904.78. And we can test that work. That 288 times pi is a 904.78. So two different ways you could have done it. If all you have to do is round to the nearest hundredth, then we could have typed that into our calculator from the very beginning. Remember, I have the 2/3 here because I took half of 4/3. Half of 4/3 is 2/3. I reduced the 2 and the 4. 2 goes into 4 twice, so now I have 2/3. Okay, this guy over here, this is going to be tricky. So, earlier, I worked with an equilateral triangle. Each ones of these sides are 8. We're going to cut it down the side, and we know that all these angles are 60. So we have this right triangle. That is a 30, 60, 90 triangle with the hypotenuse of 8. So the short leg is 4, and the height is 4 root 3. Try to write that a little bit better for you. Root 3. So that's the height of this triangle. So the triangle area equals half 8 times 4 root 3. So the area of the triangle is going to be 4 times 4, which is 16 root 3. Times the square root of 3, we'll just use the decimal version this time, 27.71. That's what one of the triangles are. Well, one of the triangles, there's actually 6 triangles here. So 6 times 27.71 times 6 gives you 166 0.28. So that's the whole area of the trapezoid. I'm sorry, not trapezoid. That's the whole area of our six-sided shape called a hexagon. So that would be our B. The volume equals base times height. The area of the base is 6 of the triangles, 166.28. The height is 10. So 166.28 times 10, don't really need a calculator for that one, 1,662.8 centimeters cubed. This here, we have a big cylinder, then we have a small cylinder, and we're going to chop out the inside of that small cylinder. So we have a big cylinder minus a small cylinder. Well, the big cylinder has a radius of 4.2. I'm sorry, 2.4. I believe that that's the total distance all the way through there. So we're going to say the big cylinder is pi r squared times the height of this cylinder, which is 10, minus the small cylinder, which is pi times 2 squared times 10. And using our calculator, we can type that in. We'll take the big one, we'll use a parenthesis and say pi times 2.4 squared times 10. That's the big one. Minus, parenthesis, we're going to subtract the small, which is pi times 2 squared times 10. That leaves us with 55 point, that would round up to become 30. Those would be inches cubed. Last one. This funny shape. We could find the area of this L shape, and then we could multiply it by the depth. To find the area of this L shape, let's come all the way through here. Your choice on if you want to come across or down. But what is our height? What is the area here? We have 80 times what? Well, if it's 60 all the way down, and it's 40 part of the way down, so it's 20 the rest of the way down. So this over here has to be 20. So what I'm going to do is say 80 times 20. That gives me the area of this rectangle. I'm going to add it to 40. And how wide is this? Well, if it's 80 all the way across, part of this that I'm not counting is 60, so the other part is 20 also. So it's 40 by 20. So that's the area of this L shape. And then we're going to take that and multiply it by the depth. How far back does that triangle, that actually L, go? That's 10. So we have 160 plus 800 it's not 160, it's 1600 plus 800 times 10, we get 2400 times 10, which gives us 24,000 millimeters cubed. We found the area of our large rectangle, then our smaller rectangle, added those together, then multiplied it by how far back it goes. Good luck on the quiz.